the UFO enigma. And Bob and I are good friends. And I talked to Bob about this and said, Bob, I read your book. It's full of equations, but the normal people aren't going to be able to capture that mentally. But I'd like to do it. I'd like to share it because I think you're onto something here. And he says, oh, please, yeah. So I have been. And you can't imagine the understanding after telling people this in language they can understand, how UFOs really work, in my opinion, and Bob's and other people's now, in Avi Loeb's, by the way. In telling people about this stuff, they've had light bulbs go off in their heads and say, it all makes sense now. Now I understand why Earth could be visited by so many different potential civilizations. And the reason has to do with how they travel. And the reason why they can be underwater and just be there, constantly for years, and not have to worry about the pressure. They don't have these massive hulls to withstand the pressure. And here's the weird thing I'm going to say. They're really neither there nor elsewhere. They're there, but not there. And whoa, what does that mean? They're interdimensional. Okay. And this goes to string theory. If you want to dive into this, we can talk about it.
I would like you to.
Okay. And we have to go all the way back to what potential universe given capabilities do these creatures use to travel? And we go back to the four fundamental forces. We have the strong nuclear force, we have the weak nuclear force, we have light, and we have gravity. Mm-hmm. All right, these strong, weak, and electromagnetic, those we understand, but gravity's that little weirdo. That's the outlier. Okay, light. Okay, yes, light, weak, and strong forces can be described with particle equations or wave equations. They can be described as particles or waves. There's duality. Mm-hmm. There's dual nature. Okay, gravity we know has waves because we saw two black holes collide or neutron stars collide, and we saw the ripples in space-time. Okay, those ripples came to our planet. We captured them with our LIGO detector, the Laser Interferometric Gravitational Wave Observatory. Say that 3 times fast. Okay. Yeah. There was one.
LIGO's better.
LIGO, yeah. LIGO's in Louisiana, Hanford, Washington, and there's one in Italy named Virgo. That one's easier. Well, the bottom line is, as those ripples passed through the Earth, we picked them up, and we saw gravitational waves. Half the duality, right? The other half would be gravitational particles known as gravitons.
Gravitons, yes.
Okay. So this next piece is the weird part. When we look at the other 3 forces, they start and end in our 4 dimensions, X, Y, and Z moving through time. Okay. That's 4 dimensions, X, Y, Z moving through time. Okay. They start and end in this 4-dimensional space. Gravity starts here, if you want to call it that, but doesn't end here. There's something weird about gravity. Right. Gravity actually seems to have the other end somewhere else. And to talk about the other end, we got to talk about what we mean by that. If you think about particles in physics, the electron, the proton, the neutron, okay, the muon, the gluon, and so on. Okay, right? Literally, yeah. You have to think of it a different way, and this brings us to the concept of string theory. Now, string theory is very complex and complicated, multiple dimensions. It makes your head spin and blow up. And now you're just a pile of flesh.
Very much.
However, if you think about it this way, it'll help you make sense. A proton is always vibrating. Okay, so we have a hydrogen atom, and it's always vibrating. The proton's always vibrating, meaning electrons going around, etc. But the proton's always vibrating. So if you stop it at one end of its travel here, and then stop it at the other end of its travel there, what's in between? The path that the proton took. And that's a little path of energy that is the string in the string theory. So instead of thinking of particles, you think of those little paths of energy, little strings.
So everything could be broken down to essentially
a set of strings.
Set of strings vibrating.
That's right. And now why would we talk about that? Because it is within the string theory concepts that this interdimensional travel becomes apparent when you think of the universe in terms of strings. So here's how that works. Within our 4 dimensions, we have these three fundamental forces we already know, strong, weak, electromagnetic, light. Okay. Gravity, now, and these have strings. The strings go out and basically they curl around and come back to our same location. Okay. So whenever we talk about the particles and the duality in here, they're vibrating back and forth like a proton. They're vibrating back and forth. The proton doesn't disappear at one end. It vibrates back and forth within our 4 dimensions. We see it doing so. We can tell. Gravity, on the other hand, if there's a particle associated with gravity, we just see one end of it. The other end is not there. Where's the other end of the gravitational particle that is also going to be vibrating, because that seems to be a universal thing? It doesn't exist in our 4 dimensions. You know where it is? It's potentially in a 5th dimension out here. So if that 5th dimension is where it is, then if we can harness the property of gravity as the universe has defined it and shown it to us, although we can't really access it yet with our technology, then we can move into this 5th dimension. And what's interesting about this 5th dimension is that this 5th dimension is highly warped. This is actually a variation of string theory called Randall-Sundrum 1, RS1. And if you can move into this 5th dimension, what you'll find is that the universe, the farther in you go to this highly warped dimension, the farther in you go, the more warped the universe is, the smaller it is around you. So you go in really far, it's very tiny around you. So let's suppose, as we'll just say it this way, say you have to travel 1 foot, okay? And you go into this 5th dimension a tiny little bit. When you come out, that 1 foot that you travel might correspond to 1.5 feet. Okay. So now that same 1 foot go deep into this 5th dimension. When you come out, that same 1 foot could have corresponded to from here to Pluto. Okay. As an example, that's not even mathematically correct. I'm just saying that's the concept. So with this concept, you could theoretically transfer far enough into that 5th dimension, okay, and oscillate back and forth so that you could, in fact, travel the universe, go light years. And all you need, actually, you don't even have thrusters or engines.
I was going to say, you don't even need combustion at that point.
There's nothing. There's no chemical rockets or nothing. What you do is you generate the particles that go around your ship that are gravitons, the ones that belong in that 5th dimension we've been talking about. And if you can do that, your ship will automatically get sucked into this 5th dimension. The more you produce, the farther in you go. Okay. And if you can go far enough into this 5th dimension, okay, you could, like I said, travel the universe. Take it another step. Let's suppose you are here on the Earth and you're an alien creature, right? Alien being, you have a ship that does this. How would you actually operate in practicality? How would that work? Well, you have to generate the particles. How do you generate these particles? These particles have a name in Randall-Sundrum 1 theory. They're identified. They're called Kaluza-Klein gravitons, or KK. Yeah, KK gravitons. Now, if that's true, then if these particles can actually exist, what you'll do, and you just Google it and you'll see it. Okay, if you actually have these Kaluza-Klein particles, you put them around your ship. They live in. Remember, the other half of them lives in this 5th dimension. So as they're generated, they're going to pull the ship into the 5th dimension, and they're surrounding your ship. Now, one of the caveats of these Kaluza-Klein gravitons is that they're 10 to the 16th times more powerful than the gravitons gluing you to your chair right now. Okay, or all of us. So what that means is they're also going to generate what are called micro black holes. And micro black holes, okay, are interesting because they only live for a nanosecond or two. They're not very long lived because all black holes evaporate. Right. They evaporate and they're gone right away, but not before they may have pulled in a molecule of air or whatever, or possibly some of the light coming to it that might go to your eye otherwise. And most importantly, not before they pull in some of the Earth gravitons and prevent them from getting to your ship. So if you surround your ship with enough of these KK gravitons, you don't feel the effects of Earth gravity at all. And this is what explains why ships could possibly be seen as fluttering leaves. Like they move like fluttering leaves with no up or down. Okay, because there's no reason, they don't feel gravity. The Earth gravity doesn't affect them, so that it looks weird to us. Okay,
right.
Now, yeah, go ahead.
Other people report seeing, like, it's almost like it's skipping.
Yes,
like skipping through. That leads me down that path as well. That sounds like it would be going in and out of the dimension.
Exactly so. And not only that, they're not actually traveling from point A to point B. They're actually traveling from point A just directly to point B without going through the space in between.
Right.
Okay, so now when it looks like they're skipping, what are they doing? They're oscillating back and forth between this fifth dimension and our four dimensions. Now, if they go into that fifth dimension a little bit, and let's say they go in for 3 inches, they might come out 100 feet of where they were, 100 feet ahead of where they were.
Mm-hmm.
Okay. Now, there's another aspect to this that we'll get to. So as they go in and out, depending on how far in they go, that will correspond to more distance they travel when they come out. So it would look like they're here, then here, then here, then here, skipping. Okay. That's what that would look like. And to our eye, we'd see what looks like a continuous object skipping across the sky because we don't know it's disappearing. We can't really see that because it's happening too fast. Okay. So the weird thing is when something goes across the sky, you might see it go like this and then boom, shoots off at a 90-degree angle. It goes, weirdly to another angle at a high rate of speed. And you will rightly say no creature could ever withstand those G-forces. And you're right. Not even alien creatures.
Right.
They're not moving at high rates of speed. If you were in their ship, all that would change for you is the outside scenery. It would feel like you feel right now. Wouldn't change. You'd be sitting in the ship and the outside would be shifting because you're oscillating back and forth between that fifth dimension and our four. And all you'd see is a new view for a moment as you're changing positions.
Mm-hmm.
Okay. Now that brings to light, well, okay, Mark, how do you produce these particles? Come on, with the goods, how do you produce those particles? All right, let's talk about how those particles are produced to actually pull you into that fifth dimension. First of all, let's go to CERN overseas. I'm going to CERN. See, it's me going to CERN.
Yes.
Okay, we get to CERN. Yeah, right. We're running there. That's going to be a long run, and I need a boat. You get to CERN, and if you go to their website and you look up CERN and Kaluza-Klein gravitons, you're going to find something really amazing. And this is the one of the more interesting parts. The Large Hadron Collider over at CERN has a detector on it called the ATLAS detector, all caps, ATLAS. The ATLAS detector, in part, is looking for, you'll never guess, Kaluza-Klein gravitons. Why? Because they're very, very interesting. Okay. Now, how would those particles be generated? Well, how is CERN generating them? With the Large Hadron Collider. And what is that? It's a particle accelerator.
Particle accelerator, yeah.
Yeah. And particle accelerators are what shape?
Oval?
Yes, circular.
Circular.
Yeah, generally. Yeah, you have linear ones too, but the circular ones are what are used to accelerate the particles to light speed, okay, or near light speed, right? So the point being, if you're going to have a particle accelerator system, that's the one, okay? If you're going to have a particle accelerator system that is going to generate these particles, you need a power source and a ring, right? You need an accelerator ring. Well, what shape are UFOs generally? There you go. Flying saucers. They're particle accelerators. I'm certain of it. Okay, now, second thing.
You just blew my mind a bit.
And that's why I got a cowboy in Texas gave me his cowboy hat for this talk. Okay, he was blown away. He put it all together. So that outer ring in a UFO is the particle accelerator. The inner part is shielded from the synchrotron radiation that's inevitable. It's a universal tenet, something we can't avoid. You try to take a charged particle and force it into a curve with a magnetic field.